Now, we are going to look at convection. And convection is also another type of heat transfer. So I want you in your books to write the word convection. Write the word convection. Convection. Write the word convection. Okay, so we are going to look at convection. Okay, look at convection. Now, remember when we looked at conduction, we say that in conduction, and who can remind us? Let me not go there. What did we say about conduction? What's conduction? What's conduction? Pav, what's conduction?
Conduction simply means transfer of heat energy through solids.
Hey, Pav, is that all? Okay.
Conduction is the process by which heat energy is transferred through solids from a region of high temperature to low temperature without movement of matter.
Very good. Very, very good. Pav, have you heard?
Yes.
Yeah. Conduction is the transfer of heat through solids from a region of high temperature to the region of low temperature without movement of matter. Without movement of what? Without movement of matter as a whole. So that is what we call conduction. Now today we are going to look at convection. Now in convection, it is almost the opposite of conduction. It is the opposite of conduction. So convection now occurs in both liquids and gases. So someone can say convection occurs in fluids. Convection, first way to write, I'll tell you what to write. Convection occurs in fluids. And since fluids are made up of liquid and gases, it means that these liquids and gases are able to move, because if you have a liquid, its molecules keep on moving within the container where you have contained it. And even the gases are, they enjoy the free movement. So gases move randomly, freely. So that's why the heat that will be transferred in liquids and gases will cause the liquids to move. That means that there is movement of matter, because these gases and the liquids, for them, they move within their what? Within the container where they are contained, or within the place where they are contained. So gases will continue moving freely, randomly, but liquids will also move freely within the container. So convection, if heat is applied, then there will be what we call a convection. The heat will be transferred from the region of high temperature to the region of low temperature. And it is these molecules of liquids and gases that will transfer that heat from the region of high temperature to the region of low temperature. Remember, as I repeat, they are the molecules of the fluids, they are the molecules of the liquids, or they are molecules of the gases that will transfer the heat from the region of high temperature to the region of low temperature. Why? Because for them, they have free movement. They have free movement. So in most cases, when heat is supplied, the molecules that are near to the heat surface or to the heat source will be energized. They will absorb that heat. They will become energetic. Those particles, those molecules, they will gain heat energy. And once they gain heat energy, they will become energetic. And when they become energetic, they will move. If they are gases, they will move up. If they are liquids, they will move up. So if you have a saucepan, you have put it on the water, or you have put it on fire, you have put it on a charcoal stove, or you have put it on an electric plate, hot plate. The water which is at the bottom, its particles gain heat fast. When they gain heat fast, they become energetic because they have absorbed the heat energy. So they gain the thermal energy and they become energetic. Once they become energetic, their kinetic energy increases and they move up to the top surface of that water. So in the due process, we shall have liquid molecules or water molecules or air particles rising. The same thing if you have a candle burning. If you have a candle burning, the air that is above the candle flame becomes very hot. That air becomes very hot. It becomes energetic. It becomes less dense and it rises. That's why when you are heating something, the air that is above rises, goes up. That's why smoke goes up, because smoke is less dense, so it rises. But I'm talking about the air that is above that flame. It becomes hot, it becomes less dense, it becomes energetic because it has absorbed the heat energy and it rises. Once it rises up, then above there is air that is at a low pressure, at a low temperature, because they say the higher you go, the cooler it does what? Neighbors. The higher you go, the higher you go, the cooler it becomes. So when you heat something, when you heat air, when you have a candle burning, the air that is heated by the candle goes up. But when it goes up, it finds air that is cold. So that air that is cold is displaced and falls down. And falls where? And falls down. So even here, this is what they are trying to say, that even if it is water that you are boiling in a saucepan, the water molecules next to that region where there is heat, they are heated, they become less dense, they become energetic, their kinetic energy increases and they rise up. So they rise up. And when they rise up to the top surface of that water, the top surface of the water is it has water which is of low temperature. So the water particles or the water molecules are of a low temperature, and those water molecules will be displaced and they will fall down. So in this way, we shall have these water particles falling down, and they are also heated. They become energetic. They absorb the heat and rise. And displace the ones which are on top, which are cold, and the cold ones now fall again. So that the process continues, and this process is what we call the convection or the convectional current. Members, are we together?
Yes.
It's what we call the convectional current. So let anyone not deceive you that convectional current is only in oceans. No, convectional current, we have seen it, that it is in fluids. So what is convection and convection current? It gives the name of the heat transfer that we are now looking at as convection, okay? So convection, this is the type of heat transfer in fluids. Just say in fluids, because fluids mean both liquids and gases. Liquids and what? Liquids and gases. So it's the type of heat transfer in fluids. From a region of high temperature to a region of low temperature with the movement of matter. So let us write in our books what convection is. What is convection? What is convection? Hope you can see. So convection, okay, so convection is the type of heat transfer. Is the type of heat what? Heat transfer. Transfer from in fluids. When we talk about fluids, we are talking about liquids or gases. Is the type of heat transfer in fluids from where? From, can say from a region of high temperature to the region of low what? Of low temperature. Region of low temperature with movement of matter as a whole. So there is movement of matter because the molecules of gases and liquids are in free motion. They enjoy the free motion. They are in free movement. Okay? That's what we call convection. That's what we call convection. So this point is very important to be noted here. I have finished writing that. This point is very important to be noted here. Sorry, here, this. So what is that point we are talking about? We are talking about this point where they are saying that convection happens when particles with a lot of heat in liquid or gases move and take up the place of the particles with less heat energy. In this way, the heat energy is transferred from the hot places to the cold places by a convection. So that's what we call the convection. So above here it is cold, but down here it is very hot. It is very hot. So there is an experiment we are going to look at there, and then we shall see even the one which we are going to do in the lab. Okay, so this is very important. We shall also note it down, this part here. And we can say that it occurs when particles, it occurs when fluid particles with a lot of heat, move and take up the place of particles with less what? With less heat energy. Full stop. Therefore, heat is transferred from a hot region to a cold one. Okay, and this causes a convection current. This causes a convection what? Causes a convection current. Members, are you there? Are you there?
Yes.
Very good, very, very good. So we are now going to do the diagram. Let us do that diagram here. Let's do the diagram. I don't know they are finished writing the notes. Let us do the diagram. That diagram. So we have the hotspot. So there is the hotspot. Hotspot. Hotspot, not the one for internet. Pub. Not the one for what? Not the one for internet. Yes, we have this and that, and then even here. Okay, something like this. So this is where we have it's cooler, it's hot. So this is what we call the convection current. So the hot region, and because here there is heat, so the molecules rise. Here molecules rise, and here they are displaced. So the less dense molecules rise up. So less dense. That's why here they are writing less dense rising. Can say less dense molecules. Less dense molecules, and here we have less dense molecules rising, and we have more dense molecules seeding or falling. Say falling or sinking to mean the same thing or the same thing. Okay. So that is the illustration of convection. That's the illustration of convection. Now we are going to look at convection in liquids. Dakia, are you there? Dakia?
Yes.
Okay, very good. Convection in liquids. Convection in liquids. Convection in liquids. Okay, there. That's where we are. So, what are they saying? Now, let me first explain before we read something here. Convection in liquids. I've already explained it to you. Now, I've told you that when you pour a certain liquid in a vessel or a container and you place that vessel on a heat source, like charcoal, or you place it on firewood that is burning, or you place it on a hot plate, not on the sun. Some of you likewise, but on small things, okay? Now, what will happen? This is what will happen. The water molecules, the liquid molecules that are at the bottom of that vessel there are going to gain heat. They become energetic. They absorb the heat energy. We say that the molecules which are residing to the bottom of the container absorb heat and become energetic. They become less dense and they rise up to the top of that liquid. So once they absorb the heat energy, they become less dense. Let me give you a scenario. Something that absorbs heat energy becomes less dense. I can tell you this. This one you have already seen it. Let me give you an example. If you get a balloon and fill it with air, and then try to burn that balloon, it will even pop before you see anything. But what will happen is that that balloon will become less dense and it will rise. The other thing that you should know is Give you an example. Anything that is heated becomes less dense. If you have a leaf and you burn it, it will turn into the ash, and then the ash will do what? It will become less dense and blown away. So anything that is heated becomes less what? Less dense. If it is air, when it is heated becomes less dense. Water molecules once heated become less dense. I'm talking about those things which are in form of fluid form. Question is there, maybe asking now, sir, we have seen people who are melting gold. When gold is melted, does it become less dense? Now, when you keep heating it, it will turn into gaseous form, and I don't know whether it can vaporize, but anything that is heated becomes less dense. You can put yourself, don't try it, please. But anything that is heated becomes less dense. Even human beings, those people who were heated in Namugongo, they became less dense and they vanished in ash. And that's why they are martyrs. They gave up their life. So even here, the water molecules that are residing at the bottom of this container, when they are heated, they absorb the heat energy, become less dense, and rise to the top of that surface, or to the top surface of that water or of that fluid. Now the molecules that are on the top surface of the fluid are displaced and they sink and they fall down to the bottom. And those molecules which fall down to the bottom, they are again heated by the heat source. So in the due process, we shall have water molecules circulating, going up and down, going up and down. That's what you call what? Kutokota. Catherine. When you see water doing what? Boiling vigorously, it means that the water molecules are now circulating, going up and down, going up and down. Let us see in these remaining 8 minutes, let us see whether we can have a video about convectional current here. And then you see, so convection in liquids use school. Okay. Convection in liquids. Let us see this.
The phenomenon of convection.
Okay. Let me share with you with a whole. Okay. Are you able to hear?
Yes.
All right.
Yes.
So let's make it bigger and bigger.
The phenomenon of convection also occurs in liquids. A volume of liquid close to the heating surface increases in accordance with the law of thermal expansion, as given by this equation, where alpha is
Don't look
the
at that
coefficient of
equation,
thermal
just
expansion.
concentrate on what they are trying to explain.
This means that the density of the liquid decreases locally, in accordance with the equation shown. Due to its buoyancy, the heated liquid then rises.
Okay, and that's the end. That's the end. So let us see. It's whether there is another one, convection in liquids. Okay, convection in liquids, convection in liquids. Let me remove fuse core. Let us see convection in water. It is also a liquid. Very good. This is the experiment. And this experiment, I think.
Introducing Speechalo, the most natural sounding text-to-speech software.
Experiment, we are going to say, I think it is familiar to what those students are doing, they are going to do. So these are 2 minutes. So let us see.
Today we are going to show the convection in water. Our apparatus are a large round bottom flask potassium permanganate crystals, a burner, a tripod stand, a spatula, and a lighter. Firstly, we are going to fill the flask with tap water. We already filled here. We are going to place it on the tripod stand. Then we are going to add some potassium permanganate crystals.
Mark the name very well. Which name has he called it? Potassium what?
Potassium permanganate.
Potassium permanganate crystal.
Permanganate crystals.
Some people have not had
Permanganate crystals.
Okay, potassium permanganate. And potassium permanganate is purple in color, so it adds some crystals of
Then we will
potassium
wait for
permanganate.
some time for the potassium permanganate crystals to settle down.
So it's going to wait until those crystals settle at the base.
And we will place our burner here.
And we now, so it's bringing a source of heat at the bottom. So it has to wait until those crystals settle at the bottom.
Then we will light the burner.
Okay. So on heating,
And let's see what happens.
we are going to see how the convection of that convectional currents are in that liquid. So water rises and then falls. So now it is rising, rising, going
When
up.
the water at the bottom of the flask is heated,
Going
it
up.
expands.
And then what happens
The
when
expanded
it
water is
up
less
there?
dense than the surrounding
We are going
water
to see.
and therefore starts to rise.
So you see
In
now
doing so,
up
the
they start
cooler regions
falling.
of
Now
the
they are
water in the
falling.
upper part of the flask, being denser, sink.
So it sinks
This
into
movement
the
of the
bottom.
liquid, due to a difference in its density,
So when it
sets
sinks
up
to
a
the bottom,
convection current,
what
as you
will
see
happen
in
is
this
that
video.
at the bottom it will also be heated again and rises. So until the whole thing is purple. For this experiment, I think he used very little potassium permanganate, but you have seen how it has risen and how it fell down back again. So that's what we call the convection in so let us see this one. Maybe this is lastly, and then we shall come back in the next chapter and rewrite the notes. So almost the same thing, so which you can try at home, but I don't think you have boiling containers. I don't think you have. So this one is going to use a candle and it's going to heat. So he has added a few crystals of potassium permanganate. Dark here, the spelling is there. That is the spelling of potassium permanganate. So that's what he has added. It is purple in color. Purple in color. So it will sink. But the moment he lights that candle, you are going to see it rising, and then afterwards it falls down. And in the due process, it causes what we call a convection current. And the convectional current is found in fluids. It is the one that makes heat to be transferred from this region of high temperature. Now at this part here there is high temperature, and up this side there is low temperature. So the molecules are now moving from the region of high temperature to the region of low temperature, transferring that heat. But once they reach there, they displace the molecules which are found there. So that means that the water now is falling, and also these other molecules of potassium permanganate are now falling down. So now they fall down as more and more molecules keep on rising. So in the due process, we have a convectional current. Convectional current is in liquids, but also a convectional current, we shall see that it is also found in gases. It is a form of heat transfer, and that is what we call the convection. The convection. So we have seen that. I think it was nice. You can try it out and then see at home, but you don't have potassium permanganate. What you can use, I don't know whether you can use iodine, something that is colored, and then can give you a clear picture of what you want to see. Okay, we go back. Now, in this experiment, we have only 1 minute that is remaining. So when we come back, we are going to write notes about this experiment and about this, and also write notes about the experiment that we have to do. Otherwise, if you have any question, please, you can ask. Any question? Any question?
Excuse me, teacher.
Mm.
There is some video I saw when someone put water in the balloon and started burning it, but the balloon did not burst. How come is it?
Okay. I think I will start with that question when we come back, because we have just microseconds remaining, isn't it? Okay, so just a small break and then we come back in the next session. Yeah. Okay. Bye.